Good morning everyone. I am Shobhan Kumar Maja from Mechanical Engineering Department of Ideal Institute of Engineering. Today we will start the online classes for the subject. The subject code is PCME 404. So discuss about the subject metrology. The word metrology is derived from the Greek word metrologia, which means to measure something. The metrology literally means the science of measurements. The purpose of this discipline is to establish means of determining physical quantities such as the dimensions, temperature, force, pressure, torque, etc. It also deals with establishing the units of measurements and their reproduction in the form of standards. The developing methods of measurement, analyzing the accuracy of methods of measurement, establishing uncertainty of measurement, and investigating the causes of measuring errors and subsequently to eliminate them. So let's start the topic systems of limits and fits. First, we discuss some basic terminologies. The nominal size. It is the size of a part specified in the drawing. It is used for general identification purpose. Now, what is basic size? It is the size of a part to which all limits of variations, that is, the tolerances applied. The basic dimension is the theoretical dimension. What is actual size? It is the actual measured dimension of the part. The difference between the basic size and the actual size should not exceed a certain limit, otherwise it will interfere with the interchangeability of the mating parts. Now, what is the limit of sizes? There are two extreme permissible sizes for a dimension of the part. The largest permissible size for a dimension is called the maximum limit or upper limit, whereas the smallest size is known as the lower limit or the minimum limit. So, before that, we discussed that the lowermost line, this is called as the datum line, which is used as the reference line, and this line is called the zero line. Then what is the limits of sizes? It is the distance between the datum line and the lowermost and the uppermost dimensions. So the distance between the datum line and the lowermost dimension is called the lower limit, and the distance between the datum line to the uppermost, that is the topmost dimension, it is called the upper limit. This one is for hole. Similarly, for shaft, from the datum line to the lower dimension, this one is called the lower limit, and from the datum line to the upper dimension, this is called the upper limit, and this one is the basic size. That is the distance between the datum line to the zero line. Okay, now what is tolerance? It is the difference between the upper limit and lower limit. It is the maximum permissible variation in a dimension. The tolerance may be unilateral or bilateral. We will discuss the unilateral or bilateral tolerances in the next class with some example. So what is tolerance? The difference between the upper limit and the lower limit. So this one is the upper limit for hole and it is the lower limit for hole. So the difference between the upper limit and lower limit, that is this distance. This is the tolerance. This one is the upper limit and this one is the lower limit. So this distance, this small distance, this is the tolerance for hole. Similarly, for shaft, this is the upper limit and this one is the lower limit. So this small distance, this is the from this point to this one, this distance is the tolerance for shaft. Now what is zero line? A straight line corresponding to the basic size. The deviations are measured from this line only. So this one is the zero line. Now what is deviation? It is the algebraic difference between a size, that is the actual or the maximum size, and the corresponding basic size. So what is actual deviation? It is the algebraic difference between an actual size and the corresponding basic size. Now what is upper deviation? upper deviation, it is the algebraic difference between the maximum size and the basic size. So which one is upper deviation? This is the algebraic difference between the maximum size and the basic size. This one is the maximum size this one, and this one is the basic size which corresponding to zero line. So this one is the upper deviation. And what is lower deviation? It is the algebraic difference between the minimum size and the basic size. So what is lower deviation? Algebraic difference between the minimum size and the basic size. This one is the basic size and this one is the minimum dimension. So this gap is the lower deviation. This one is for hole. Similarly for shaft, what is upper deviation? The algebraic difference between the upper limit and the basic size. So this one is the upper limit and this one is the basic limit. So this one is the upper deviation, this gap only. And what is lower deviation? The algebraic difference between the minimum size and the basic size. So this one is the basic size correspond to the zero line, and the minimum limit, that is the lower limit. So this gap is the lower deviation. This gap is the lower deviation and this gap is the upper deviation for shaft. Okay, now what is the mean deviation? It is the arithmetical mean of the upper and lower deviations. It is the arithmetical mean of the upper and lower deviations. So what is fundamental deviation? This is the deviation, either the upper or the lower deviation, which is nearest one to zero line for either a hole or a shaft. We will discuss the fundamental deviations and other things with some example in the next lecture. Thank you.